guys, today we are going to do lesson 11.3 on solving radical equations. So the first thing we're going to do is start with the definition of what is a radical equation, and it's a pretty easy definition. It is an equation that contains a radical sign. And remember that a radical sign is just another name for the square root sign. All right, now, we already talked about how if we had an equation that looked like x squared equaled 25, for example, that the way that we undo that squared number is to take the square root. And that works because squaring a number and taking the square root are inverse operations, just like addition and subtraction and multiplication and division. So today we're going to have equations that have a square root sign, and to undo it, we are going to square each side. Because again, taking the square root and squaring a number are inverse operations that undo each other. So if two expressions are equal, then their squares are also equal. So if A equals B, then we know that A squared must also equal B squared. This is the idea that whatever we do to one side, if we do it to the other, it stays balanced. So if I have that the square root of x equals 4, then to undo that square root or that radical sign, I need to square that side, because the square root sign and squaring a number undo each other, so this would just be x. But just like with all equations, whatever you do to one side, you also have to do to the other side, and so 4 squared is 16, and so the solution to that equation would be that x equals 16. All right, so let's try this with a slightly more complicated equation that has a few more steps in it. So it writes out the steps for you on the side, so let's follow those. We're going to start by rewriting the equation. So 2 times the square root of x minus 8 equals 0. Okay, now my goal is I'm trying to get x by itself. And so I need to take steps towards getting the x by itself. And in this case, it's not just the x, it's the square root of x. So my first step is to try to isolate that square root sign. So to do that, I'm going to first add 8 to both sides. Then I'm going to divide each side by 2. And I get that the square root of x equals 4. Again, my first goal is to get that square root sign completely by itself. Now, I don't want what the square root of x is, I want what just x is. And so to undo that square root sign, as we just talked about, I need to square it. And whatever I do to one side, I have to do to the other. So the solution here is that x equals 16. All right. Now let's do a check step. You can either do it down below, or I'm going to do it over to the side because that's where I have space. And because these are equations, we are going to do check steps to make sure that our solution worked. So I have 2 times, you can put a multiplication symbol there if you want, the square root of 16 minus 8 equals 0. Now when we talked about expressions that involved radical signs, we talked about how the radical sign is a grouping symbol, and therefore it comes first in the order of operation. So if you have a square root sign, you first have to do anything that's under the square root sign, then take the square root, then anything on the outside. So there's nothing to do underneath, so I'm going to take the square root of 16, which is 4. And again, we're going to, in these problems, just focus on the positive square root, because that'll keep this a little bit simpler. So then I have multiplication. 2 times 4 is 8, and 8 minus 8 is in fact 0, so we know we found the correct solution. All right, let's turn the page and try the next one that is similar but has one extra step to it. So I have 4 times the square root of x minus 7 plus 12 equals 28. All right, so I'm going to start by trying to get the square root sign by itself. So I need to start by subtracting 12 from both sides, which gives me 4 times the square root of x minus 7 equals 16. Then I'm going to divide each side by 4, which gives me the square root of x minus 7 equals 4. Now that the square root sign is by itself, I need to get rid of the square root sign. I can't get rid of the square root sign until it's completely by itself, but now it is. So to do that, to undo the square root sign, I need to square this side, and whatever I do to one side, I have to do to the other. So that's going to give me x minus 7. You're not squaring what's under the square root sign because that squaring is just undoing the square root. So it basically just takes away that square root. So now I have x minus 7 equals 16. And I just have one more step here to get x by itself, and that is to add 7 to both sides, which gives me x equals 23 as my solution. All right, let's go ahead and check it to make sure that we found the right solution. So I have 4 times the square root, and for x I'm going to plug in 23, so that's 23 minus 7 plus 12 equals 28. All right, again, when you have an expression with a radical sign, you first do what's under the radical sign, then take the square root, then anything on the outside. So I need to start by doing 23 minus 7. So this would be 16. Then I'm going to take the square root. So the square root of 16 is 4. 4 times 4 is 16, and 16 plus 12 is 28. So I know I found the correct solution. All right, now let's try one that has a radical sign on both sides. So notice here that on each side of the equal sign, I have a radical sign. So I'm going to start, as always, by rewriting it here. So I have 3x minus 17 equals the square root of x plus 21. And because I have a radical sign on each side, I need to get rid of that on both sides. And so the way I'm going to do that is by squaring both sides. Because again, whatever I do to one side, if I do it to the other, it will stay equal. So then this would just be 3x minus 17 equals x plus 21. By squaring it, we got rid of the radical sign on each side. And now this is an equation that has variables on both sides, but we've solved equations like that quite a bit before. So I'm going to start this by subtracting x, or if it helps you, you could think about that as 1x. That gives me 2x minus 17 equals 21. Then I'm going to add 17 to both sides, which gives me 2x equals 38. Then I'm going to divide each side by 2, and that gives me x equals 19. Now that's not the only way to solve it. We've talked about when we have variables on both sides, I could have subtracted 3x from both sides, or I could have started by moving the constant, and all of those would have worked out as well as long as you did the correct mathematical steps. So the way I solved it is not the way you have to, but I think it was kind of the easiest way because it kept the coefficient positive. All right, so let's try our check step now. We go back to the original. There's 2 x's, so I'm going to plug in 19 for each of those x's. All right, so then I do 3 times 19, which is 57, minus 17, equals 19 plus 21, which is 40. Well, 57 minus 17 is 40. So I end up with the square root of 40 equals the square root of 40, and we know we could square both sides there and just get that 40 equals 40. So again, I know my solution of x equals 19 worked. All right, why don't you try 1 and 2 now? Try to solve and check them. And then when you're ready, press play again to check your answers with mine. All right, so go ahead and check your answers with mine. You'll notice that my first steps in both of these were to get the square root part by itself. So I had to add on each one, and then on number 1, divide. And once my square root sign was by itself, that's when I squared both sides and then worked on whatever was underneath. Just so you know as well, I know on number 2, some of the numbers get just a little bit bigger. You're welcome to use your calculator as long as you show all of your work. But if that helps with the multiplication or division, that is totally fine. All right, we are going to skip 3 and 4 because they're similar to ones we've already done, and we're going to move down to number 5 and 6. These will be the last 2 that we do. So on number 5, you'll notice that we have a square root sign on both sides, and the square root sign is by itself on each side. So the first thing that we want to do is square both sides. That gives me x plus 4 equals 2x minus 1. And now I have variables on both sides. So we've solved problems like this many times before. We want to get the variables to one side. I'm going to do that by subtracting x. But as we've talked about, there are other ways you could do it as well. Then I'm going to add 1, and I end up with 1x, or just x, equals 5. And then I can do my check step. I go back to the original, so I have the square root of 5 plus 4 would equal the square root of 2 times 5 minus 1. So this would be the square root of 9. Over here, 2 times 5 is 10, but 10 minus 1 is also 9, so the square root of 9 equals the square root of 9, or I can say 9 equals 9, and so that one worked. Let's look at number 6 now. Notice on number 6, we have 2 square roots on one side and 0 on the other side. So you might be tempted to think that you can start off by just squaring each side. The problem is when you square that left side, it would not just get rid of those radical signs. Actually, you would need to do some distributing because it would be the square root of 4x minus 3 minus the square root of x times the square root of 4x minus 3 minus the square root of x. So it would be really complicated. So unfortunately, that method does not work for us. We instead need to get one radical sign on each side. So that's going to be, thankfully, pretty easy to do. I'm going to start by adding the square root of x to each side. So that then on the left side, all I'm left with is 4x minus 3. And on the right side now, I have the square root of x. Now this looks like the problem in number 5. And so now that I have one radical sign on each side, now I can square both sides, which gives me 4x minus 3 equals x. Then I need to get my x terms to one side. So I have negative 3 equals negative 3x. Be careful with those negative signs. I'm going to divide each side by negative 3, and I end up with x equals positive 1. And now I'll do a check step. So remember to go back to the original. I have the square root of 4 times 1 minus 3 minus the square root of 1 equals 0. Well, 4 times 1 is 4. 4 minus 3 is 1. And the square root of 1 minus the square root of 1 is 0, because anything minus itself is always 0. So that worked for me. So just make sure that you only have one radical sign on each side of the equal sign before you square it. All right, good luck with your worksheet on this. The big key is to make sure that you get the square root sign by itself before you square each side. Have a good day.